All right, we're going to talk about laws of probability. So here we have a Venn diagram, and whenever that you see the word or, that means we're going to be dealing with union. Okay, and union can be written as with the letter U, so A union B. And so let's first start off with probability of being in circle A is being inside the yellow region, which is region A plus region B over the total. The total is A plus B plus C plus D. Okay. Now the probability of being in region B, which is the blue circle, is lowercase b plus lowercase c over the total. Okay. Now we were just talking about the union. The probability of the union A and B is we've got to be in region A, B, and C, these lowercase a, b, and c. Now the intersection, this is also known as, when we have intersection, it means and. So A and B, and it is only the part that overlaps, which is B, okay, over the total. So in part II, they asked for probability of A or B, and so A or B is this. This is probability of A or B. Okay, so now we're going to do IV here, which is the probability of A plus the probability of B minus the probability of A and B. So probability of A is here from above, probability of B is here from above, and minus the probability of A and B. So A and B is the intersection of the two circles, which is this. Now let's look here. Let's just focus on the numerators. I've got A plus B plus C minus B. So this plus B and this minus B is going to cancel out, and then we're just left with one B. So we have A plus B plus C. And when we have this, we realize, hey, look, we've got A union B. So this is the proof to show that the union is equal to the probability of A plus the probability of B minus the intersection of the two. Now the reason we have to subtract this intersection is because when you do probability of A plus the probability of B, you've counted this little lowercase b section twice. So since we've counted this lower intersection b twice, we need to subtract it. Okay, let's do this first example. Probability of A is 0.6. A union B is 0.7, and this intersection of AB is 0.3. So I'm going to use this part right here. The intersection of the two is 0.3. Okay. So now I know that probability of being A is 0.6. So if this is 0.3, then we know this has got to be 0.3 also, because these two here have to add up to 0.6. Okay, now this next part here says that the union has to be 0.7. So this thing here plus this thing here plus this thing here has to add up to 0.7. So that means this has to be 0.1, because 0.3 plus 0.3 plus 0.1 adds up to 0.7. Okay, so now we've got my correct Venn diagram, and this says what is the probability of B? And so B is this circle here. So we have to add those two things together, and we get probability of being in circle B is 0.3 plus 0.1, which is equal to 0.4. Be careful using capital letters when you're talking about the name of a circle, and lowercase letters when you're talking about the names of regions. Okay. here we've got, let's just use this one here. You've got 31 people on a tour bus. 7 are born in Scotland. 5 were born in Wales. Are S and W mutually exclusive? And the answer is yes, because you can't be born in Scotland and be born in Wales at the same time. They're separate regions. Okay, so the first question says, if a member on the tour is chosen at random, what's the probability that they're born in Scotland? So, first of all, there's 7 that were born in Scotland, so my numerator is going to be 7, and the denominator has to be the number of people on the bus, 31. All done. That's it. We probably should write it like this. Probability, capital S, equals. Okay. Now, what's the probability that somebody's born in Wales? Well, it's going to be, we should write it like this. P W equals that. Okay, because there's 5 of them. All right, and what's the probability of Scotland or Wales? Or it's going to be union, right? So S union W. So if it's union, then we're simply going to add these two fractions together. Because if this is my Scotland and this is my Wales, we add those fractions together, and that's going to give me the probability that they're born in Scotland or Wales out of all the people on the bus. Okay, let's look at the next one here. The probability of being A is 0.4. So we know that this here has to be sum of 0.4. The very first thing I look at is this right here. Okay, we know that the intersection is 0.1. So the very first thing I wrote down was that this here has to be 0.1. Then I know that this whole yellow circle has to be 0.4, so this has got to be 0.3 because these two have to add up to 0.4. The next thing I looked at was here. The union has to be 0.9. So if the union has to be 0.9, then if that's 0.3 and that's 0.1, this is going to have to be 0.5 because 0.3 and 0.1 is 0.4 plus 0.5 is going to give me 0.9. And so now we can answer the question, find the probability of being in B. And to be in circle B, it's these two added together, which is 0.6. Okay. Let's do 2 together. Okay. I solved this one algebraically. Okay. The probability of x is being 0.6. I'm going to label this as A, B, and C. Definitely use lowercase letters. So the probability of being in circle X is 0.6, so I could say lowercase a plus lowercase b is 0.6. The probability of being in circle Y is 0.5, so lowercase b plus lowercase c is 0.5. And the union of these is going to be A plus B plus C. So all 3 of these regions has to add up to 0.9. Okay, and now we need to solve for the different letters. And we're trying to figure out what is the intersection of this. So we're trying to find lowercase b. So the first thing I did when I was solving this is I said, okay, well, you know that a plus b is 0.6, isn't it? So I could just do a substitution and replace this with 0.6. 0.6 plus c equals 0.9. So if I subtract 0.6 on both sides, c equals 0.3. So I'm going to just write that here, 0.3. Okay. Now I can say, all right, we know that this circle here has to be 0.5, right? So if that has to be 0.5, then I know this has to be 0.2. because 0.2 plus 0.3 is going to give me 0.5. And since they're asking me to find the intersection of x and y, we know the intersection is going to be b. So we can say that p x intersection y equals 0.2. Okay, let's do the next one. A and B are mutually exclusive. That means they do not intersect. Okay, so okay, B is 0.45. The union, these two together, is 0.8. So all I have to do is just subtract, and I'm going to get 0.35. 0.35. Because the union is going to be these added together. And there's no overlap, so I don't have to worry about any additional math. All right, next one. Okay, so the ticket numbers are numbered 1 through 15, are placed in a hat. One ticket is chosen at random. Let A be the event that the number drawn is greater than 11. So the sample space for A is numbers greater than 11. So 12, 13, 14, 15. Okay. Let B be the event that the number drawn is less than 8. So B is going to have a sample space less than 8. So the numbers 1, 2, 3, 4, 5, 6, 7. That's the sample space. So are these mutually exclusive? Can you have these numbers and these numbers at the same time? You can't have them at the same time, so the answer is yes. It is mutually exclusive because you can't be in have this sample space and this sample space at the same time. So let's answer the first question. What is the probability of being in circle A? So being in circle A, how many values are there? 1, 2, 3, 4. So there's 4 values out of 15 total. Okay, probability of being in B. Okay, 1, 2, 3, 4, 5, 6, 7. So you have 7 values out of 15 cards. Okay, I. Okay, what is the probability of A union B? So the probability of A union B is going to be these fractions added together. So 4 over 15 plus 7 over 15 is going to give me 11 over 15. Now, I know they didn't ask this, but what if they said, what is the probability of A intersection B? Well, you know that they don't intersect, so it's going to be the null set, which means no values. Okay. All right. Last question. The class consists of 25 students. 11 are 15 years old. 12 are 16 years old. 8 students own dogs. 7 students own cats. 4 students do not own any pets. So the first thing we know is the age is mutually exclusive. Right? You can either be 15 or 16, but not both. And owning a pet and not owning a pet is mutually exclusive. So you need to think about this first, okay? And at first I tried to do a whole bunch of different Venn diagrams, and then I realized, whoa, this isn't working. So then I started thinking, okay, let's look at this in terms of mutually exclusive. Okay, so the probability of being 15 years old is simply 11 out of 25. There's 11 people 15 years old, 25 students total. Okay, what is the probability of being 16 years old? Well, that's going to be 12 out of 25. Question C. What is the probability of having a dog? Well, there's 8 people that have dogs, so that's 8 over 25. Question E. What's the probability of not having a pet? Well, there's 4 people that don't have pets, so 4 out of 25. Question F. Okay, what's the probability of being 15 years old and being 16 years old? So the probability of the union of 15 and 16 years old is going to be equal to the fractions added together. So 11 over 25 plus 12 over 25, which is going to give me 23 over 25. That means there's 2 students who are neither 15 or 16 years old. Okay, I know they didn't ask this, but what's the intersection of the 15 and 16 years old? That's going to be 0. You can't be 15 and 16 years old at the same time. Okay. Question G. What's the union of 15-year-olds and dog owners? We don't know how many 15-year-olds have dogs, so this one can't be done, because we don't know how many 15 years old people have dogs. The same thing with this one here, one can't be done. We don't know how many cat owners and dog owners own both, so that we can't do that one. Now let's look at question H. P probability of C union N. So owning a cat and not having a pet is going to be 7 over 25 plus 4 over 25, which is going to give me 11 over 25. Okay, last one, J. The probability of owning a dog and not having a pet. So owning a dog is 8 out of 25 plus 4 out of 25. This is owning the dog. This is not owning a pet. And that's going to give me 12 out of 25. If you need extra help, you might want to hit pause and rewind. And that's the answers for this activity.